Okay, the next problem we're going to do is a problem that we did in class. You're part of a citizens group evaluating the safety of a high school athletic program. To help judge the diving program, you would like to know how fast a diver hits the water in the most complicated dive. The coach has his best diver perform for your group. The diver, after jumping from the high board, moves through the air with constant acceleration of 9.8 meters per second squared. Later in the dive, she passes near a lower diving board, which is 3 meters above the water. With your trusty stopwatch, you determined that it took 0.2 seconds to enter the water from the time the diver passed the lower board. How fast was she going when she hit the water? Okay, the first thing we want to do is focus the problem. We want to give a picture and give the given information. So, I show the two boards, the lower board and the upper board, the diver diving from the higher board, the time it takes to go from the lower board to the water, and the distance between the lower board and the water. So it takes 0.2 seconds to fall from 3 meters to the water. Now the question is, how fast is the diver entering the water? So what is our approach? Well, given that we know the acceleration, perhaps we can only examine the last 3 meters to get the answer. So our next step is to describe the physics. So looking only at the last 3 meters, we have the object, the diver, at point y0 equals 3 meters with some velocity v0y, and we'll call that t0 equals 0. Then we have the diver at yf equals 0 with some final velocity vfy at tf, the final time, equal to 0.2 seconds. Over here on the right hand side, we've defined all our variables. The velocity 0y is the velocity of the diver at the lower board. V sub fy is the velocity of the diver hitting the water. A is the acceleration, which is minus g. Y0 is the height of the lower board, and yf is 0. Now we want to decide on our target quantity. Our target quantity, of course, is V sub fy, the velocity of the diver as he hits the water, or she hits the water. Now, we want to ask, what are the quantitative relationships that play into this problem? Well, we need a quantitative relationship, of course, with the velocity of the final hitting the water, the velocity of the diver at the lower board, the final time, the initial time, and gravity. And our first relationship is velocity, or V sub Fy, equal V sub 0y minus g acceleration times the final time minus the initial time. We also have another relationship that the average velocity in the y direction between the lower board and the water is the velocity of the diver at the lower board minus the velocity of the diver hitting the water. That should be plus over 2. And the average velocity in the y direction of the diver is also equal to the final position minus the initial position over the final time minus the initial time. And you'll note that in the average middle term I have corrected the sign. Now we're on to planning the solution. So we want to start with an equation that contains the target quantity. So I've started with this equation, the velocity of the diver as he enters the water equal to the velocity of the diver as he passes the board minus the acceleration of gravity times the change in time. Next, I put another equation down, and I'm using this equation right here, that the velocity of the diver as he enters water is equal to 2 times the average velocity of the diver minus the velocity as the diver enters the water. Now what I want to do is I want to take this value and substitute this value here for v0y. And I get this equation, that the velocity of the diver as he enters the water is equal to 2 times the average velocity of the diver minus the velocity of the diver as he enters the water minus acceleration of gravity times the displacement in time. Now we already know we have also an equation for the average velocity. So I'm going to take the average velocity and substitute it into this quantity right here, and I have my final equation, that the velocity of the diver as he enters the water is equal to the average velocity minus the acceleration of gravity times the change in time divided by 2. Of course, we want to make sure that we keep track of the units, and the only units here are meters and seconds. There are no other mixed units. There's no feet, there's no kilometers or anything. We're only dealing with meters and seconds, so there's no conversions to make. Now we're left with planning the solution, or executing the plan. So I'm going to take my final equation right here, and I'm going to substitute my numbers. So the final position is 0, the initial position is 3, and the time is 0.2 minus 0 minus 9.8 times 0.2 over 2. And the answer is minus 15.98 meters per second. So the diver enters the water at minus 15.98 meters per second. Finally, we want to evaluate the solution. So it asks for the velocity entering the water, and we have given that. We've given exactly what it asked for. And how do we know whether it's reasonable or unreasonable? Well, we could evaluate whether or not what the speed of the diver is entering the water, if in fact he had just fallen from the 3-meter board. And we know that his velocity would be less. So we expect the velocity to be more. So we take this as a reasonable answer. And is it complete? Well, yes, it's complete because we have given exactly what has been asked for, the velocity of the diver as he enters the water.